We are looking at enhancing the number run project from the YByte Python curriculum available at www.ybyte.in. In this video, we look at this very interesting extension where we will try to make the game more interesting by providing the player some hints while the guessing is going on. For example, we can tell the player, if the number is even or odd, if the number chosen is divisible by 3, if the number is a prime number, the sum of digits of number, and in fact, so many other things. I leave it as a challenge for you to think of some more interesting hints and see if you can implement them in your projects. But I'm going to stick with these and see how we can, get a structure for all this so that you can then definitely extend it. Now, one question that comes up is when do we give hints? And there's really two ways that I could think of. One is that, well, I can give hints after a certain number of attempts. So which means, let's say, after first 5 attempts or something, I say, okay, look, now you can get some hints. That's a fair thing. Or we can make it more like, lifeline. So you say, okay, let's give the player a choice. Whenever the player asks for a hint, we just give it. And, that's also fine. However, we need to keep track of which hints we are giving because there's no point in giving the same hint twice. So, that we have to keep track regardless of which effort we're going. Now, we are going to take the second approach where I will ask the player whenever the player wants a hint, we will just provide the hint. So what we will do is that we'll use a Boolean flag called hints to be given, like true or false. So basically every attempt we'll ask the user if a hint is wanted, and we set this flag to true. And if the hint is, let's say, once basically all the hints have been given, then we again set this flag to false and we do not change it. So let's see at a high level what we are going to do. So here's the code that I'm going to do. So I'm going to use, let's say, hint as a number 1. Hints to be given is false. Again, I come into my loop. I ask my player, first thing first, I ask my player, well, would you like a hint? If the hint wanted is yes, which means the player responds yes. And I have not given all the 4 hints, which is, I say hint less than 5. Then I say, okay, I'm going to give you a hint. Otherwise, there'll be no hint provided. So, let's put this in code first. So remember, I come in here to my project. I'm going to stop this thing right now. So my code is actually, yeah, so I come in here, like I said, I'm going to define a variable called hint. Let's say set it to 1. Basically, this means a hint number. And a Boolean flag say hints to be, say, given. And I set it to false to start with. So, in the beginning, I set it to false. Now, everything else remains pretty much the same. But like I said, the moment I come in here, I ask my player if a hint is wanted. So I say hint, say, wanted is equal to, say, input. Would you like a hint? And, if the person, let's say, responds yes, or, uh, you know, uh, let's say, and so if the person responds yes, and I'm not yet given all the hints, then I will set this flag to true. So I just go and say, well, if, say, hint, wanted is equal to, notice 2 equal to's, and I say yes, and let's say hint is less than 5. Now this is 5 because I have 4 hints, like I mentioned. So it's, I say, okay, if I've given all 4, then I'll not give any more. So if it's less than 5, I say, okay, let's say hints to be given is equal to, say, to say true, because I'm going to give some hints over here. We'll see how that is done later. Else I'll set this up to, let's say, hints to be given, I'll set this to false, because in either of these conditions, either the player is not asking or I provided all the hints. Remember, this is an and condition, both of these must be true. But if this is not true, then I say, okay, look, I cannot be providing any more hints. Now, with this done, let's first take a look at the top level view here. Once this is done, like I said, I'm going to put up an if loop, if condition. I say, okay, look, if hints to be given is true, which is this, I'm going to give you a hint, and I'm going to put all my 4 hints as, let's say, hint equals to 1, hint equals to 2, 3, and 4. And at the end of all this, I'm going to increase hint by 1. So hint will go from 1, 2, 3, 4. Hint will become 5 after 4 hints, and that's why this code will stop working. I mean, this will basically set the hints to be given to false, and no more hints will be given. Now, before I write this code, let's me sort of, let's say simplicity, like I said, let's consider 4 hints. We offer them one by one in exactly this order. So first hint, like I said, number is even or odd, number is divisible by 3, number prime, sum of the digits of the number. Now, make sure that, now notice that not all of these hints may be very useful, because, for example, if the number is divisible by, say, 3, then we clearly know the number is not prime, and so on. So, you can always make this more better, more intelligent. In fact, a very interesting challenge here would be, can you think of offering these hints in a random order while still giving only one hint at a time. Now I'll give you a hint here. Think lists. It's like repeating, it's like generating random numbers but without repetition. We have seen this before in, for example, in our memory game in Scratch. Think in those lines, but I'm going to keep it simple. Let's say these four in this exact order. Like I said, you can do more hints, less hints, but the ideas are similar. So let's look at these hints one by one. First one is very simple. If the number is even or odd, well, if n modulo 2, n is the chosen number. If n modulo 2 is 0, then the number is even, else it is odd, because if the remainder division by 2 is 0, then that definitely the number is even. Likewise, so divisible by 3, I just check for n modulo 3. Checking for a prime number is obviously a little bit harder, but again, I'll give you the high level picture of the logic here. 1 is not a prime, 2 is the only prime, so I just look at the number. If it's 1, I declare not a prime. If it's an even number, if it's not a 2, then it's not a prime, but if it's a 2, then it is a prime. Um, in fact, I should In fact, I should add that else condition here so that for 2, a prime is returned. We'll do that as we write the code. Else, which means the number is an odd number. Basically, again, this is a for loop, which means that I'm checking for every number. The idea here is, and that's what is important, I'm just trying to check that if this number is not divisible by any other number that's smaller by it, then it's a prime number. Now, this code, basically it's a for loop. So it goes, let's say, from 2, 3, 4, 5 until, let's say, middle of the range. If the number is divisible by any of the numbers, then it's not a prime. I break off. On the other hand, if the number is not divisible by anybody, then it is a prime. So, try to get the big picture, and that's sufficient here. Finally, the sum of the digits. Well, this is very interesting. Remember, I have to find something like sum of, let's say, a number 123. The digits of that are 1, 2, and 3. And I do that by converting that to string because that allows me to now iterate over this string, right? So I say for kk in, let's say, n string. Now we're going to learn about for loop later, but basically it's a repeat loop with a variable. So this kk iterates. It takes on the different digits of the number. I convert that to integers, get their face value, and then keep adding them to sum. So the sum of digits of number is, let's say, this sum. So now what we will do is that we'll just implement all this first. It's going to take a while, but like I said, let's get the big picture in place, and one by one we can implement, and then we can see this all working, right? So I go and say, for example, if say hints to be given, and now if this is true, then I'm going to start giving my hint and say, okay, look, if hint say is equal to 1. Now remember, my 1 was even or odd, so I just go and say, look, if that is the case, let me just maybe I can just go and yes, I'll just do that. If let's say n modulo 2 is equal to say 0, then I just say print, sorry, so I don't need this. This is the case. Say print, say number is even, and else I'm going to put, let's say, print, say number is say odd. All right. Now the second hint would be, so if this is the case, this was my first hint. I go and look at my second hint, very similar to this. So I say my second hint here is, if my, so if hint is equal to 2, so if hint is equal to 2, I say, okay, look, if number is divisible by 3, then I say number is, say, divisible by 3. Else, let's say number is not divisible by 3. Now the third hint is a little bit more involved. That's the prime numbers. So I'm just going to say, okay, let me just put this code over here. If let's say hint is equal to 3, so this is searching for a prime number. I'm going to say, look, if n is equal to 1, then definitely not a prime. So I just put, say, print, say number is not prime. Else, so I'll use an elif here, which means basically like a big brother of if else. So I say, okay, if this doesn't happen, let's search if the number is an even number. So I say if n modulo 2 is equal to 0, which means it's an even number. I go and say, look, if n is not equal to 2, which means because 2 is the only even prime number. So I say if n is not equal to 2, then I just put here print, let's say, number is not prime. Now again, the fact that this guy is telling me, let's say these lines, it means that this code can be optimized a little bit, but that's okay. I leave that as an exercise. Number is not prime. Else here, which means that n is equal to 2. So I just say print, for example, number is prime. And, finally, I come into, let's say, the else here, which means I'm looking at odd numbers. Now here, I'm going to set up a loop. I'm going to set up a for loop. So basically checking for every number smaller than this to see if there's a divisibility. So I say I do this from, kk in range. So from, let's say, 2 till the, sort of mid of the range, right? So this is an odd number, remember? So it's not really divisible. It's not divisible by 2. So I do integer divided by 2 plus 1. So I basically check, kind of the middle range. If I find that if n percentage k is equal to 0, which means the number is divisible, it is clearly not a prime number because it is a number, something divides it. So I say print, let's say, um, number is not prime, and I can just break at this point, which means I don't need to check any further. On the other hand, if I find that I've completed this entire loop, which means that my kk has become equal to, let's say, int of n over 2, then I just print, let's say, number is prime. Now this is quite elaborate. In fact, it may also help, to kind of create a function here using a def statement and then just return a boolean whether the number is prime or not. But I just kept it simple here, don't want to add too many complications. But that is something that you can think about, right? So this is, um, done for hint equals to 3. For hint equals to 4, now again I have to be very careful of the indentations. These all have to be at the same level. So I just say hint equals to, let's say, 4. This is where I'm finding the sum of the digits. So I say, okay, let me convert this number to an, let's say str, say n, and I'll show you why this code works and, the logic for this. So I say sum is equal to 0. Let's say for kk, say kk in n, say str, which is a string version of the number that we had. I'm just going to say sum is equal to sum plus, let's say, int of kk. So converting that kk into integer and then adding it to sum. And once that for loop exits, I can just print here. Again, indentation is very, very important to this. So I say print, for example, let's say the sum of the digits is, and I can put say sum over here. Now, before I do anything else, let me just show you how this piece of code is working so that it gets a bit more clear. Let's say my number is, let's say, 342. Now, when I'm doing nstr, it's becoming, I say convert this to a number. So it's becoming, so nstr is 342. Sorry, n underscore str is actually 342 as a string. Now, what I'm doing is that I'm doing basically int of, say, 3 plus int of, say, 5 and plus int of, let's say, int of, let's say, 2. So with that, okay, so I made a mistake here. That is 10 because 3 plus, so I should have done 3, 4, 2 actually. So 3 plus 4 is 7 plus 2 is 9, and that will be the sum of my numbers. And that's how this thing is working. I'm just converting to string and going character by character to that. Now with all this done, very, very important that I increase hint. So hint equals to hint plus 1, and I do this because I want to make sure that my hint increases, and I go to the next hint all the time. And also once I finish all the hints, then there are no more hints to be given. So I just want to make sure my code is in good shape. I just kind of I said compress this a little bit so that I can understand the indentations correctly. Notice this is nice. If everything is inside this, of course, this indentation. Okay, so why is this? So this is wrong. I've made a mistake here. This should have been. Let me just extend this. This should have been over here because this is a part of hint equals to 4, right? So with this done, I think my code is in a better shape. This is actually powerful. So if I did this, yeah, now it's nice. So notice it's if hints to be given, then I give either hint 1, 2, 3, 4, and I increase hint by 1. And with this, my code will work. Let's see it in action, because that makes it quite interesting. So let's say I say, okay, look, oh, so there's an invalid syntax. Let's see, line 75. What is the problem here? So line 75 and Okay, so the mistake here is basically I've put two of this. Okay, so that's the problem. I hope it runs after that. All right, so it tells me, well, I've selected a number between 1 and 1024. Can you guess? Now, the first thing it asks me, would you like a guess? So I'll say, no, I don't want a guess. All right, it says, then guess the number. Let me try 512. Right in the middle, it says larger than that. Would you like a hint? I say, no, let me just narrow it down a little bit more first, and then I'll take a hint. I try, let's say, this plus 256. So let's say 768. Notice I'm going in the binary, search type of mode. Larger than that, would you like a hint? Let me just try to go narrower down a little bit. Let's say I will try something like maybe 900. Oh no, I don't want a hint. So I tried. Okay, so guess the number. I say 900. Larger than that. Okay, now let's take a hint, right? So my number is between 900 and 1024. I would like a hint. I says yeah. Okay, so I made a mistake. I should have said yes. So let's say I say 920. My number is larger than that. This time I do want a hint. So I say yes, number is odd. So 920 was not a great guess. Number is an odd number, right? Now I need to go between 920 and 1024. Let me try something in between. Let's say 900, let's say 961. Let's just try that because it's an odd number. So I guess that my number is smaller than that. And I say, yes, I do want a hint. My number is divisible by 3. So it's between 920 and 961 and it's divisible by 3, right? So this means that the sum of digits is also divisible by 3. I can try, for example, let's say 900 and it's an odd number. So we know that it cannot be 926. Can it be, let's say 927? Let's try that. 927. This is divisible by 3 for sure, right? It's larger than that. Would you like a hint? Yes, I would like a hint. It says my number is not prime. Well, this hint doesn't really help me. I knew that number is not prime because it's divisible by 3. But let's just try that again, right? It's an odd number divisible by 3. So it can't be 930. It can be 933. It can be, let's say, 939. Let's just try 939. It says my number is larger than that. Okay, so this is getting quite interesting. The number is between 961 and 939 and we're almost there. Would you like a hint? Yes, I say yes, I would like a hint. That sum of digits is 21. Now that's not too surprising because we're looking at large numbers. There's already 900 something. So 1 is 9, which means the other two digits add up to 12. So 939 was actually a great guess. 948 would add up to 12. 966 would add up to 12, but of course that's more than 961. I would try to go 957. 957 would be my guess. Let's see if that works. And indeed, that was correct. Now, notice how knowing these guesses simplified my journey. I got it in 8 attempts, right? Whereas binary search tells me that it'll take me 10 attempts. So the guesses did help me in this case. Obviously, made the game quite a bit interesting as well. At obviously expense of some work, right? So this is how it goes. I hope you found this interesting. In general, if you think this way of learning programming is fun, it makes you think, it makes you, build activities, enhance them, look at our website because that's how we learn programming. Thank you so much. Enjoy programming.